Welcome back. This is section 1.5 equations. So in this section, we're going to look at different types of equations and how we can find the solutions to those different types of equations. Okay, so first off, an equation, the values of an unknown that make an equation true are going to be called the solutions or the roots of that equation. So anytime you see either of those terms, they both mean the same thing. The process for finding those solutions is just called solving an equation. So two equations with exactly the same solutions are what we call equivalent equations. Now, some properties of equality. So if A is equal to B, then A plus C has to be equal to B plus C. In other words, we can add the same value to both sides of an equation and it'll keep the same value. Okay, so that equation will still be true. Same thing works for multiplication. If A is equal to B, then C times A is equal to C times B, provided that C is not equal to 0. Okay, so we can't multiply by 0 because then that would just give us 0 on both sides. So we have to multiply by some non-zero constant. Now, if we have a linear equation, it's going to have one variable, and it's going to be in the form ax plus b is equal to 0. Okay, so a and b are going to be real numbers, and then x is going to be the variable that we're trying to solve for. So that's our most basic type of equation that we're going to look at solving now. All right, so here's our first equation. We've got 7x minus 4 is equal to 3x plus 8. And we want to solve this equation. So what we have to do in this case is we need to get all of the variable terms to one side, and we need to get all of the number terms to the other side. So it doesn't matter what order you do that in as long as you do that first. Okay, so I'm going to go ahead and move my x terms all to the left-hand side here. And to do that, I'm going to subtract 3x from the right-hand side. Okay, so to get rid of a positive 3x, we need a negative 3x or just subtraction by 3x. Now, remember our properties of equality said we have to do the same thing on both sides to keep the equation balanced. So I'm going to come to the other side, and I'm going to do exactly the same thing. And when I do that, 7x minus 3x should give us 4x. I'm going to bring down the minus 4. And now on the right-hand side, 3x minus 3x cancels out, and so all that's left there is that positive 8. Now that I've got all my variable terms to one side, now I need to get all my number terms to the other side. So I've got this minus 4 here. I need to combine it with the positive 8 on the other side. To get rid of a minus 4, we need to add 4. So I'm going to add 4 to both sides of my equation again. That's going to leave us with 4x is equal to 8 plus 4 is 12. And at that point, all we have left is 4 times x is equal to 12. Well, to get rid of multiplication, the inverse operation is going to be division. So I need to divide both sides of this equation now by 4. So when we do that, 4 divided by 4 gives us 1x. So we just have an x on the left. And then 12 divided by 4 should give us 3. And so now the solution to this equation is x equals 3. Now, the nice thing about equations is you can actually substitute back into the equation to check yourself just to make sure it's correct. 7 times 3 is 21. 21 minus 4 is going to be 17 on the left-hand side. Then if we do the right-hand side, 3 times 3 is 9, plus 8 is also 17. Since 17 is equal to 17, that tells us that x equals 3 is the correct solution. All right, so now we have one variable in terms of another. So we're trying to solve this equation for the variable capital M, and we've got all these other variables that we have to deal with. But basically, all we're trying to do is get that capital M by itself. So we have to think about what processes we can do to make that happen. Well, I notice here that I have this r squared in my denominator, which means I'm dividing by r squared. Well, I'm going to go ahead and move that first. So to get rid of division, the inverse operation would be multiplication. So I'm going to multiply both sides of my equation by r squared. Now, in this case, there's nothing that can be combined because all these variables are different. And so all we're left with on the left-hand side is f times r squared. And now on the other side, the division and multiplication of r squared are going to cancel out. And so we're left with g, lowercase m, capital M. Now at that point, again, I'm trying to solve for capital M. So I'm going to get rid of the g and the lowercase m at that point. All of that is being multiplied. The inverse operation of multiplication is division. So I'm just going to divide. And I can actually divide by both of those at the same time. So I'm going to divide by g and lowercase m, which means I need to go to the other side and do exactly the same thing. And so now, again, we can't really do anything with any of these variables. We can't simplify this fraction because none of them are like terms. And so all we're left with is f times r squared divided by g times m, and that's going to be equal to capital M. And at that point, we are done. We've isolated the capital M, and we know what it's equal to in terms of the other variables. All right, so now we have a surface area of a closed rectangular box shown in the figure. It can be calculated by the length, the width, and the height according to this formula here. So to find surface area, we're going to do 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height. We want to take that equation now and we want to solve it for W. So we want to get W in terms of the other variables. So again, I'm going to start with that equation. A equals 2LW plus 2WH plus 2LH. Well, notice we have two terms that actually have a W in them. Okay, so the only term that I'm going to move first is the one that's just 2LH because it doesn't even have a W term at all. So to get rid of that 2LH, I'm actually going to subtract 2LH from both sides. Now, A and 2LH are not like terms. I can't combine those. So this is just A minus 2LH is equal to 2LW plus 2WH. Now, since we have two terms that have the W in common, and W is the variable we're trying to solve for, what we're going to have to do next is factor out the W that we're trying to solve for. So my left-hand side does not change. But now I'm going to factor out just the variable that I'm trying to solve for, so just the W. If I do that from this first term, all that's left is 2 times L. And then if we factor out the W from the second term, that's going to leave us with 2 times H. Now, since we want to get W by itself, I need to get rid of everything that's in those parentheses, the 2L plus 2H. Well, I'm multiplying W times that. Inverse operation of multiplication is division. So I'm actually going to divide both sides by 2L plus 2H. And so when we do that now, that entire factor cancels out, the 2L plus 2H. And so this is going to give us A minus 2LH over 2L plus 2H is equal to W. Now, you always want to look for anything that might be able to be simplified. In this case, though, there's no common factors in the numerator, no common factors in the denominator, and because of the addition and subtraction here, we can't go out and go through and cancel out any of these terms, right? So be careful. Don't try to cancel out L's. Don't try to cancel out H's because those are not just like terms that can be canceled out at that point. So this right here is our final answer. All right, now quadratic equation. So a quadratic equation is any equation that can be written in the form ax squared plus bx plus c, where again a, b, and this should be c, are going to be real numbers, and a cannot be equal to 0 because then you wouldn't have an x squared term if it was. Okay, so a, b, and c are real numbers, x is still our variable, and a cannot be equal to 0. Now, the zero product property is what allows us to be able to solve quadratic equations. So a times b is equal to 0 if and only if either a is 0 or b is 0. Okay, so for that product to be equal to 0, we know that one of those values has to be 0. And so what's going to happen here is we're going to be able to factor a lot of these quadratics, and then we're going to know that one of those factors has to be equal to 0 so that the product can be equal to 0. All right, so here we go. We're trying to find all the real solutions of this equation. So as soon as we see that x squared, that tells us we do have a quadratic equation. The first thing we're always going to want to do with quadratic equations is try to set them equal to 0. So in this case, I've got a 24 on the right-hand side. I want to move that to the left and make this equal 0. Well, positive 24, the inverse is negative 24. So I'm going to subtract 24 on both sides. That's going to give us x squared plus 5x minus 24. Since none of those are like terms, we can't combine anything. And then 24 minus 24 gives us 0. Now, once we set it equal to 0, we want to see if we can factor. Okay, so I'm going to think about my factors here. I'm going to try to break this into two binomials. To get x squared, we need x and x. So I'm going to start with that. Now we think about our factors of 24. Well, there's several options here. So 6 times 4 would give us 24. 8 times 3 would also give us 24. 12 times 2 could work, or 24 times 1. Now in this case, we know the signs are going to have to be opposites in order to get a negative 24. So I know one of these is going to be a positive and one of these is going to be a negative. And so now looking at my options over there, the only one of those that could give us a 5 in the middle is going to be the 8 and the 3. And since I want this to be a positive 5x, that means my larger value 8 needs to be the positive and my smaller value 3 needs to be the negative. Now that we have our factors, based off the zero product property, we know that if these two things multiplied together are equal to 0, that means that one of the factors has to be 0, okay, because that's the only way I can multiply and get 0 as my answer. So either x plus 8 has to be equal to 0, or x minus 3 has to be equal to 0. Now we solve. So just like we did before, to get x by itself here, we're going to subtract 8 on both sides. That's going to give us x equals negative 8. And then for the other one, the opposite of subtraction is addition. So I'm going to add 3 to both sides to get x by itself. And that should give us x equals 3. So in this case, with this quadratic equation, we actually get two solutions to this equation. X is equal to negative 8 and x is equal to positive 3. So again, just to recap, set your quadratic equation equal to 0 first. See if there's a way to factor it. If there is, then that's what we want to do. And then we can just set each of those factors equal to 0 and solve for x from there. Now, if it's a simple quadratic, meaning it's just x squared equals some numerical value, then all we really have to do is take the square root of both sides of that equation. And so we're going to get a positive square root of c and a negative square root of c. So that's the key here, is just to remember that you're going to get the positive and the negative version, because squaring either of those will give us a positive c value. So when you square a negative, you get a positive. When you square a positive, you still get a positive. So here's some examples of simple quadratics. We've got x squared equals 5. So again, rather than trying to set this equal to 0 and factor, which it won't factor, we can actually just take the square root of both sides here, since it's just x squared equals a constant. So I'm going to take my square root of both sides. The square root of x squared is going to leave us with just x. And then remember, we just said we could get the positive or the negative square root here. So we just have to put a plus or minus square root of 5. So we can't take the square root of 5. It's not a perfect square. You can't simplify that. So x equals plus or minus square root of 5 would be our solutions. And notice there are two answers there, positive square root of 5 and negative square root of 5. Now, in terms of homework in WebAssign, there is no plus or minus. And so you're going to have to enter these as separate values. So your solution would be square root of 5, comma, negative square root of 5. Okay, so just keep that in mind. Since there is no plus or minus, you will have to enter them as two separate values. On a test, however, plus or minus is perfectly fine. All right, now the next one here, we've got x minus 4 squared is equal to 5. So again, I could actually expand out the x minus 4 squared, move the 5 to the other side, set it equal to 0, and see if it factors. However, it's going to be a lot easier in this case because I have something squared equal to a numerical constant. I can just take the square root of both sides. So I'm going to go ahead and do that just to get rid of that square. When I do that now, that's going to leave us with x minus 4. And just like the previous one, we're going to get a positive or negative square root of 5. Now, this time my x is not by itself yet, so we still need to do a little bit more work to make that happen. I need to get rid of this minus 4. To do that, we're going to add 4 to both sides. So I add 4. That gives me my x. And notice here, square root of 5 and 4 are not like terms. I can't combine those, and so all we're left with here is 4 plus or minus the square root of 5. Okay, or plus or minus square root of 5 plus 4. Either way, either order there is perfectly fine. Okay, but it is a positive 4 and then a plus or minus square root of 5. Again, in WebAssign, you're not going to be able to use a plus or minus, so you're going to have to separate this. So our solutions will be 4 plus the square root of 5 and 4 minus the square root of 5. But again, on a test, I'm perfectly happy with this solution right here with the plus or minus. Now, completing the square is another option if you're trying to solve a quadratic. So if we have something in the form x squared plus bx, to make that a perfect square, we're going to take the b value, divide it by 2, and square it. Okay, and that's going to give us a c value for our quadratic now. Okay, so that b divided by 2 squared becomes our c value. And then once we do that, then we have a perfect square trinomial, and we can actually factor it. Okay, so that's why we use this formula now, is to create a perfect square trinomial that we can then factor. All right, so we want to find the real solutions of each of these equations. Now, looking at this first one, notice 13's factors are only 13 and 1. That's never going to give us a negative 8x in the middle. So this one's not going to factor, right? So if it factors, that's always going to be your best bet. But if it doesn't, now we have some other options. Okay, so I'm going to use completing the square to solve this one now. Now, if we're completing the square, the first thing we have to do is create some space for a new c value. So to do that, I'm going to move the original c value, the 13, to the other side of my equation. So I'm going to subtract 13 from both sides. Okay, so that's going to give us x squared minus 8x. Now, I'm going to leave some space right here because I'm going to insert a new c value, but that's going to be equal to negative 13 on the other side now. Now, once we've done that and we've moved that c value, now we can use our formula. So remember, we're going to do b divided by 2 squared. Now for this one, our b value is negative 8. So I'm going to take my negative 8, I'm going to divide it by 2, and I'm going to square it. Well, negative 8 divided by 2 should give us negative 4, and negative 4 squared is going to give us 16. So that now is the new c value if I'm going to complete the square. So we get a positive 16, which means in this space that I left here, I'm going to put a plus 16. Now keep in mind, our properties of equality, we can't just go and throw a plus 16 in there. Whatever you do to one side of an equation, we have to do to the other. So if I put a plus 16 there, I have to put a plus 16 on the other side also. Now, if we've done everything correctly, what we've created on the left-hand side now should factor. We should have created a perfect square trinomial. So let's see if we can get factors for this one now. Factors of x squared are x and x. Factors of 16, and because it's a perfect square trinomial, we want to get the exact same factor in both. So the only way that's going to work is for both of these to be a 4. Now we need the signs. Well, it could either be negative, negative, or positive, positive to give us a positive 16. But because we want a negative 8 in the middle, that tells us it's going to be negative, negative. Now, One thing I'm going to tell you is if you look back at the steps that you used to find that C value, whatever value you had in your parentheses before you squared, that's always going to be the value that goes in your parentheses here. Since we had a -4 before we squared, both of those are going to get a -4 in your factors. Now on the other side, -13 plus 16, that's going to give us a +3. At that point, x minus 4 times x minus 4, we can actually write as x minus 4 squared since both of those are the same factor. So we have x minus 4 squared is equal to 3. And now we have a problem that looks very similar to the previous example where we have something squared equals a numerical constant. So I can actually take the square root of both sides. So we're going to take the square root here, take the square root here. That leaves us with x minus 4 equals, don't forget we need a plus or minus square root of 3 now. And then I'll bring this up here to finish it out. So once we have x minus 4 equals plus or minus square root of 3, our last step is to isolate the x. So I need to move the 4 over. That means I need to add 4 to both sides, which gives us x equals +4 plus or minus the square root of 3. And so our solutions here would be 4 plus square root of 3 and 4 minus square root of 3 if you were typing those into WebAssign. So again, completing the square is a very good option if it does not factor to begin with, right? Then we would move the C term, find a new C term to create a perfect square trinomial, factor that, take your square root, move everything to one side, and then we have our x values. All right, now this next one, similar steps, okay? I'll go ahead and tell you it's not going to factor, so I'm going to go ahead and move the 6 over first. So I'm going to subtract 6 from both sides. And that leaves us with 3x squared minus 12x is equal to -6. Now, something that's different about this one is we actually have a coefficient in front of our x squared. So before we can complete the square, we need to actually factor out that value. Okay, and notice I said just that value, not the x, just the 3. So I'm going to factor out a 3 here. That's going to leave us with x squared. And I also have to factor out the 3 from the -12x. So that's going to leave us with a -4x. So now, instead of using -12 as the b value, we're actually using this -4 that we're left with after we've done that factoring. Okay, so that's the one additional step here, so don't forget that. So now if I take my -4, I divide it by 2, and I square it, -4 divided by 2 is -2, and -2 squared is +4. So that tells me I'm going to get a +4 as my new c value. Now, whatever we do to one side, we have to do to the other. Be careful here, though. We're not just adding 4 to the left-hand side. We're actually adding 3 times 4 to the left side. Since there's a 3 on the outside, that 3 would get distributed. So really what we're adding is 12. So I actually need to add 12 to the other side. So anytime you factor out a value like that, just remember it's going to get multiplied by the c value that we've put in there. So whatever that product is, that's what we actually need to add to the other side now. All right, so now we can do some factoring. We can combine like terms. So this is going to give us 3 times. And now in terms of my factors, we're going to get an x and an x. We know that the factors of 4 need to be the same. So it's going to be a 2 and a 2. And because we want to end up with a negative in the middle, they're both going to be negative. And again, if you look back here, that -2 is what we're going to use in our factors now. On the other side, we have -6 plus 12. That's going to give us +6. Again, we can rewrite this now as 3 times x minus 2 squared equals 6. Now this time, before we can take the square root, we need to get the x minus 2 squared by itself. To get rid of that 3, we're going to have to divide by 3. So I'm going to divide both sides by 3 here. And I'll bring this up here so we can finish it out. It's going to leave us with x minus 2 squared is equal to 2. And now we can take the square root of both sides, which is going to give us x minus 2 is equal to plus or minus the square root of 2. And then finally, we need to get the x by itself. So I'm going to add 2 to both sides. Again, we can't combine that with the square root. So now we have x equals 2 plus or minus the square root of 2. And again, just a reminder, in WebAssign, you'll have to write that as 2 separate answers: 2 plus square root of 2, 2 minus square root of 2. So again, on a problem like that, just don't forget we have to factor out the a term, the 3 in this case, first. And then don't forget that because we've done that, whenever we find that c value, we actually have to distribute that 3 to whatever that c value is, and that's what we're actually going to add to the other side. Now, quadratic formula. Okay, so here's another option, especially for things that do not factor. Quadratic formula is nice because it works for all quadratics, no matter what. So if you don't see how something factors, even if it does factor, you could use quadratic formula and you will get the correct solutions. Okay, so again, we're looking at a quadratic here. A cannot be equal to 0, but our formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you have a catchy little tune to help you memorize that, that's perfectly fine. I actually learned one when I was in high school, so I'm going to try to sing it for you real quick. So the way I learned this was negative b plus or minus square root b squared minus 4ac over 2a over 2a. Okay, so if that helps you to remember that, by all means, go back and rewind the video and listen to it over and over and over again. But whatever you need to do to memorize this formula, you need to know how to do quadratic formula. Okay. All right, so we're going to use quadratic formula and see if we can solve some of these now. So the first one we've got is 3x squared minus 5x minus 1 is equal to 0. Right, so our first step is we need to be able to identify what the a, b, and c values are. Okay, so for this first one here, our a value is going to be 3. The b value is going to be negative 5. Okay, so make sure you keep the sign with that value. And the c value is actually going to be a negative 1. So now we're going to substitute into our quadratic formula, and then we'll simplify from there. So we have x equals, we have negative b. Well, since b is already a negative, when we take the opposite of that, it becomes a positive. So we get positive 5 plus or minus the square root. Then we have b squared, which is negative 5 squared, minus 4ac, so minus 4 times 3 times negative 1. And all of that goes over 2a, which is going to be 2 times 3 in this case. Right, now we simplify. Okay, so I keep my 5 on the outside, so 5 plus or minus the square root. Negative 5 squared is going to become a positive 25, because when you square a negative, it becomes positive. When we multiply a minus 4 times 3 times negative 1, that's actually going to give us a positive 12 now. So we get plus 12 all over 2 times 3, which is 6. And now we can actually add the terms inside the square root here. So we get 5 plus or minus the square root. 25 plus 12 is 37, all over 6. The square root of 37, you cannot break down. You can't take the square root of 37. And so this right here would actually be our final answer. And so our two solutions here would be 5 plus the square root of 37 over 6, and 5 minus the square root of 37 over 6. All right, now let's take a look at the next one. So again, we want to try to use quadratic formula and get our solutions to this one. So we have x equals, we're going to do negative b, which in this case would be a negative 12, plus or minus the square root of b squared, so 12 squared, minus 4ac, so 4 times 4 times 9, all over 2a, which is 2 times 4. Again, I'm going to keep my negative 12 on the outside, plus or minus. 12 squared is actually 144, so we get 144. Then we have minus 4 times 9. That's actually going to give us minus 144. And then 2 times 4 in the denominator is going to give us 8. Now, if we subtract what we have in the square root, we're actually going to get a 0 now. So we get negative 12 plus or minus the square root of 0 divided by 8. Well, the square root of 0 is just 0. And so now we just have negative 12 plus or minus 0 divided by 8. Well, whether I add 0 or subtract 0 from negative 12, it's going to give me negative 12 regardless. And so really this can be simplified now to negative 12 over 8. And if you take that fraction, 4 actually goes into the numerator and denominator here. And so we can get negative 3 over 2. And so there is our solution to that one. Now, you might be asking yourself, well, wait a minute, we've been getting 2 solutions for all these other ones. Why did we only get 1 solution for this one? It all comes down to the fact that we got a 0 under our square root here. And so adding or subtracting actually gives us the same value. And so this solution that we found down here, we would actually call a double root. Okay, so root, remember, just means solution. But because we have a quadratic in this case, we should get 2 solutions. We only get the 1. We would say that that one actually happens twice. Okay, and so we call it a double root. Now, we could have also actually factored this one. So if you went back and looked at it, 4x squared plus 12x plus 9 would actually factor into 2x plus 3 times 2x plus 3. We get the exact same factors in both, and that's why when you set both equal to 0, we actually get the same solution to both. All right, now the last one here, again, we want to use quadratic formula. So we've got x equals, I'm going to start with our negative b, so that's negative 2, plus or minus the square root b squared, which is 2 squared, minus 4 times a times c, so that's 4 times 1 times 2. And all of that now is going to go over 2a, which is just 2 times 1. All right, so from there, negative 2 on the outside, plus or minus square root. 2 squared is 4. Negative 4 times 1 times 2 is going to give us a negative 8. And then 2 times 1 in the denominator is just 2. When we subtract here, 4 minus 8 is going to give us a negative 4. So we get negative 2 plus or minus the square root of negative 4 all over 2. Now, if we get a negative under the radical, at this point in the class, we're going to stop right there and we're going to say, wait a minute, we can't take the square root of a negative. This right here cannot happen. And so there are no real solutions to this equation. Okay. Now, that's not to say that there aren't any solutions to this equation, because eventually we will look at how to find those solutions, but there are no real solutions to this equation if you have a negative under your square root. So we've looked at 3 types here. One where we just get a positive value under the square root. That was the first one we did. One where we get 0 under the square root. That's going to give us that double root. And then we could also get a negative under the square root. And in that case, we would just say there are. So A way that we can actually test to see how many solutions we're going to have without having to do the entire quadratic formula is just to focus on the stuff that's under the square root. So notice here, this is what we call the discriminant. So the b squared minus 4ac part, that's what's under your square root. If we just calculate that, anytime that value is positive, greater than 0, then we're going to have two solutions, right? Because we're going to have the plus or minus on the outside of the square root. We're going to get two real solutions. If that discriminant equals 0, then we're going to have one real solution. And again, we would call that a double root. And then if we end up with a negative value under that square root as the discriminant, then we're going to say that there's no real solution to that equation. Okay, so again, this is just a quick way to determine how many solutions does the equation have without having to do the entire quadratic formula. All right, so again, we're just going to go through this time and use the discriminant to figure out how many solutions there are. All right, so the discriminant here, remember, formula is b squared minus 4ac. So that's all we're looking at. So for this first one, b squared would be 4 squared minus 4 times a times c. If we simplify that now, that's going to give us 16. Negative 4 times 1 times negative 1 is going to be a plus 4. And when we add that, we get 20. So now the question is, do we get a positive value, 0, or a negative value? In this case, it's a positive value. So that tells us that we're going to have two real solutions. Now, if you want to define those real solutions, then you'd have to do the quadratic formula to find them. But we already know the value that goes under the square root, so that already simplifies that process for us. Now, if we look at the next one, same thing. We're going to look at our discriminant. We're looking at b squared, which is going to be negative 12 squared, minus 4 times a times c. Again, if we square the negative 12, that's going to give us positive 144. Negative 4 times 9 is going to give us a negative 144. That's going to give us 0. And so remember, if we get 0 as our discriminant, that tells us there's going to be one real solution. And again, that real solution we would call a double root, but there's only going to be one value there. All right, and then the last one down here, we got d equals negative 2 squared minus 4 times 1/3 times 4. In this case, we're going to get negative 2 squared is 4. Negative 4 times 1/3 times 4. 4 times 4 is 16. 16 times 1/3 is minus 16 thirds. Now, to be able to subtract that, you would need a common denominator. Common denominator will be 3. So this actually becomes 12 over 3 minus 16 over 3, which is negative 4 over 3. Now, all we really care about is whether it's positive, negative, or 0. In this case, it does come out as a negative value. And so that tells us then that there are no real solutions to that equation. So again, positive discriminant, 2 real solutions. 0 discriminant, 1 real solution. Negative discriminant, no real solutions. All right, example 10. Okay, so we want to solve this equation. We've got 3 over x minus 2 over x minus 3 is equal to negative 12 over x squared minus 9. Now, to solve this equation, the first thing we're going to want to do is set it equal to 0. Okay, so I'm actually going to move the negative 12 over x squared minus 9 to the other side. Because it's negative, I need to add it to move it to the other side. So this is going to give us 3 over x minus 2 over x minus 3. And then that becomes a positive 12 over x squared minus 9. and that's going to be equal to 0 now. Now, to be able to put these together, we need a common denominator. So first thing I'm going to do, I'm going to factor the x squared minus 9 just to see what factors I have there, and then we'll figure out what that common denominator is going to have to be. So again, this is still just 3 over x. I'm actually going to leave myself some space here so I can fill in those common factors. 2 over x minus 3. And then plus 12 over, this is a difference of squares now, so this is going to give us x minus 3 and x plus 3. And that's equal to 0. All right, so now if we look at all of those denominators, remember to find the common denominator when you have multiple factors like that, you need all the factors in all the denominators. So I have an x minus 3, an x plus 3, and an x. Those are the 3 things that I'm going to need in all 3 of them now. So the first one is missing the x minus 3 and the x plus 3. So I'm going to multiply by x minus 3 and x plus 3, which means I need to go to the numerator and do the same thing. Now the next one, we have the x minus 3, so we're missing the x, and we're missing the x plus 3. I'm going to multiply this by x and the x plus 3, which means I go up to the numerator and do exactly the same thing. And then the last one, we already have the x minus 3 and the x plus 3. We're just missing the x. So I just need to multiply top and bottom by x this time. All right, so now we have a common denominator because we have the x, x minus 3, and x plus 3 and all 3 of those fractions. So now I can actually put them together. So this is going to give us 3 times x minus 3 times x plus 3 minus 2x times x plus 3 plus 12x all over our common denominator, x times x plus 3 times x minus 3. And again, that's all still equal to 0. All right, now we have to simplify that numerator. So I actually need to multiply all this stuff out. Well, x minus 3 times x plus 3, that's going to give us x squared minus 9 because we know that's what we factored to get that. So this is going to be 3 times x squared minus 9. Now I can distribute the negative 2x to both of my terms here. That's going to give us a negative 2x squared and a negative 6x. And then I'm just going to bring down the plus 12x that we had before. Denominator still x times x plus 3 times x minus 3. And so now we can actually distribute the 3. So we get 3x squared. 3 times negative 9 is a minus 27. We get a negative 2x squared minus 6x plus 12. And then we have our x times x plus 3 times x minus 3. All right, now we need to combine like terms in our numerator. We'll have a 3x squared and a negative 2x squared, so that's going to give us an x squared. We have a negative 6x that doesn't combine with anything else, so I'm going to get a minus 6x. And then we have a negative 27 and a plus 12. It's actually going to give us a negative 15 over x times x plus 3 times x minus 3. Now we want to look and see if we can factor. Okay, so if I look at my numerator, x squared minus 6x minus 15, I'm going to try to factor that into two binomials. Factors of x squared are x and x. So now we need factors here of 15. Okay, and so if we look at the factors of that, oh, I apologize. I dropped an X at the previous step, and that's why this is not factoring. So let me back up and let me fix that. Okay, so notice at this previous step, this should have been a 12X at the very end there. And so that means when I combine my like terms, we are going to get an X squared, but now we're going to have a negative 6X plus 12X. That's actually going to be a positive 6X. And then we're going to have a minus 27 because the 27 is not going to combine with anything. Okay, so I do apologize for that. I just left off the X on that last term there. All right, now let's see if that factors. Okay, so we're going to have, again, X and X to give us the X squared. And this time, our options for 27, we could use 9 and 3, 27 and 1. The one that's going to work to give us the 6, though, is the 9 and the 3. And because we need a negative, we know the signs are going to have to be opposites. I need a positive in the middle, though, so the bigger value is positive, smaller value is negative. And then our denominator is still the same. Right, now, for this fraction to be equal to 0, the numerator is what's going to need to equal 0, because 0 divided by anything is going to give us 0. So what I'm going to do now is I'm actually going to take my two factors just from the numerator, and I'm going to set them equal to 0. So I have x plus 9 equals 0, and x minus 3 equals 0. Because remember, the denominator, if it's equal to 0, the whole thing's undefined. So what we care about is the numerator being equal to 0 now. Well, to solve these, I'm going to subtract 9. That's going to give us x equals negative 9. And for the other piece, I'm going to add 3. That's going to give us x equals positive 3. Now, we have to be careful on problems like this because our original equation could have had restrictions on what the x value could have been. So anytime you have fractions, anytime you have square roots, we need to go back and double check and make sure that we don't have solutions that don't work. So all I'm really checking here is to make sure none of these will give me 0 in a denominator. So if I take the negative 9 and I go back and substitute it in, that first fraction, I'm going to get negative 9 in the denominator. Perfectly fine. If I substitute it into the next one, negative 9 minus 3 is going to be negative 12. Perfectly fine. If I plug it into the last one, negative 9 squared is 81. 81 minus 9 is 72. Perfectly fine. Negative 9 works. Okay, so again, I'm just double checking to make sure that I don't get a 0 in any of those denominators. If I do, then I can't use that solution. So now we're going to test the other one. So we have a positive 3. So if I substitute it in, again, I'm going to start with the first one, plug it into x, positive 3, perfectly fine in the denominator. Now I'm going to look at the next one. 3 minus 3, that's 0, right? We can't have 0 in a denominator, so automatically this solution does not work because I can't get 0 in the denominator of my original equation now. So for this one, we're actually only going to end up with one solution, x equals negative 9, and that's all. So again, whenever you solve equations like this with fractions with x's in the denominator, just always go back and substitute those values and make sure none of them give you zeros in a denominator. All right, now equations involving radicals. So this time we're trying to solve for x, and again, we have this square root in our equation. The first thing we're always going to want to do when you have an equation with a square root is we want to get the square root by itself. Okay, so I need to isolate that square root, which means I need to get rid of this 1. Since it's a positive 1, I'm going to subtract 1 from both sides. Now these are not like terms, so that's just 2x minus 1 equals the negative square root of 2 minus x. Now at that point, I'm going to go ahead and get rid of the negative also. So remember, that's like a -1 in front of that square root. So I can actually just divide both sides by -1 at that point. That means I'm dividing both terms on the left-hand side by a -1. So 2x divided by -1 is -2x. -1 divided by -1 becomes a +1. And now my square root just becomes positive square root of 2 minus x. Now, at that point, we can actually square both sides to get rid of our square root. So I'm going to square the square root, but that means I also need to square this entire side. Notice I'm grouping everything together there and squaring it all together, not just squaring each individual term. All right. So if we square -2x plus 1, remember what that means is -2x plus 1 times -2x plus 1. So we're actually going to use FOIL here to multiply this out. -2x times -2x is going to be a positive 4x squared. Outer term, -2x times 1 is going to give us -2x. Inner terms, 1 times -2x is another -2x. And then last terms, 1 times 1 should be a 1. Combining our like terms in the middle now, we get 4x squared minus 4x plus 1. So that's actually what we have on the left-hand side now. Now on the right-hand side, when you square the square root, those cancel each other out, and all we're left with is 2 minus x. Now that we've eliminated the square root, now we have a quadratic equation. So we're going to try to set this equal to 0, see if it factors. If it doesn't, then we'll use one of our other methods to solve. But to set this equal to 0, I need to move the 2. So I'm going to subtract 2 from both sides. I also need to add an x. So I'm going to go ahead and do that in the same step here. And so now we're left with 4x squared. -4x plus x is -3x. 1 plus a -2 or 1 minus 2 is going to give us a -1. And now everything on the right cancels out, and so we get a 0. Now we're going to see if we can factor this. Okay, so create your two binomials. I notice here that I have a -1 as my factor at the end. The only options there are +1 and -1, right? So I know for sure that that's what has to go in there. That's going to help us to figure out what the other two factors are. So I know I need to get a 4x squared. That's either a 2x times 2x or 4x times 1x. But because we want to get a -3x in the middle, that tells me I'm going with 4 and 1. Okay, so I'm going to go with 4x and 1x. Now it's just a matter of where they go. In this case, the 4x would actually go here so that it gets multiplied by the -1 when you do your outer terms. And then the x is going to go here so that it gets multiplied by the +1. So we get a -4x plus 1x, and that gives us the -3x that we want in the middle. Okay. So now we're going to actually set each one of these factors equal to 0. So we have 4x plus 1 equals 0, and x minus 1 equals 0. This first one, first step, we have to move the 1 to the other side. So we're going to subtract it. So we get 4x is equal to -1. And now to get rid of the 4, we need to divide. So we get x is equal to -1 over 4. And then the other one, we're only adding the 1. So that's just going to give us x is equal to +1. Now, just like I told you with the fractions, we have to be careful. We have to be careful whenever there's a radical involved also. Okay, so I've got to go back now and actually substitute these values in. And it's not enough just to make sure we don't get a negative under the radical. We actually need to test these values and see if both sides actually come out equal to each other. Okay, so I'm going to plug in the -1/4 back in the original equation. So that gives us 2 times -1/4 is equal to 1 minus the square root of 2 minus -1/4. Well, 2 times negative 1/4 is actually going to give us a negative 2 over 4 or negative 1/2. So we have negative 1/2 over here. On the other side, we have 1 minus. And now we're going to have the square root of 2 minus a negative 1/4. Well, if we do that, that's the same thing as 2 plus 1/4. Common denominator would be 4. So that's 8 over 4 plus 1 over 4. And that's going to give us 9 over 4. So we get 9/4 under our square root now. Now remember, one of our properties for square roots is if we have a fraction inside, we can actually take the square root of the numerator, square root of the denominator. Both of those are perfect squares. So we're going to have 1 minus square root of 9 is 3, square root of 4 is 2, so we get 3 over 2. And now we need to do 1 minus 3 halves. So 1 minus 3 over 2. Again, we need a common denominator. Common denominator is 2, so 2 over 2 minus 3 over 2 is going to give us a negative 1/2. So we have negative 1/2 is equal to negative 1/2. That is a true statement now, and so that tells us that negative 1/4 is one of our solutions. Now we need to test the 1 and make sure that it also works. Okay, so again, I'm going to substitute into the original equation. So we have 2 times 1 is equal to 1 minus the square root of 2 minus 1. In this case, 2 times 1 is 2. 1 minus, and then the square root of 2 minus 1, that's going to give us the square root of 1. Square root of 1 is just 1, so we get 2 equals 1 minus 1. 1 minus 1 is 0. And so in this case, 2 is not equal to 0. So this is not a true statement anymore. And so we can say that 1 is not actually a solution to that equation. So our only solution this time is x equals negative 1/4. Okay, so that's what I was saying before. We have to substitute it into the original equation, make sure that those solutions actually work, because in some cases they will not. Now, it could be that neither one of your solutions work. It could be that both of them work, right? So don't just assume that once you find one that works, the other one's not, because it is possible for both to work. It is possible for neither to work. All right, now the ones that don't work are what we call extraneous. Okay, so whenever you see that term extraneous, just think extra, right? That's the root of that word. So we end up with these solutions that are extra that don't actually work in the original equation. Okay, so we call those extraneous solutions. All right, so now fourth degree equation of a quadratic type. And by that, we mean that there's 3 terms here. And so we might actually be able to factor this one. Okay, so that's what we're going to try to do with this. See if we can actually factor this. So I'm going to break this into 2 binomials. It's already set equal to 0 for us. So now I'm going to think about my factors of x to the 4th. Well, there's several options actually. However, because this is of a quadratic type where we're trying to get 2 binomials, I'm going to use x squared times x squared, because I'm actually going to want the same quadratic in both. So we want to use x squared and x squared. Now we're going to look at the 8. Well, my factors of 8 are either 8 and 1 or 4 and 2. Well, unfortunately, neither one of those is going to give us the negative 8x squared that we want in the middle. Okay, so we can't actually do this by factoring now, which means we're going to have to use one of our other options. In this case, quadratic formula is where we're going to go. Okay, so I'm actually going to do my quadratic formula on this, even though it's an x to the 4th to begin with. Okay, so we're going to say x squared equals, because once I do my quadratic formula, this is only going to give me the x squared values. So we're going to get negative b, which is 8, plus or minus the square root of b squared, which is negative 8 squared, minus 4 times a times c, all over 2 times a. Okay, so again, we have our 8 on the outside, plus or minus the square root. Negative 8 squared is 64. Negative 4 times 1 times 8 is going to be a minus 32. And then 2 times 1 is 2. 64 minus 32 now, we're going to get 8 plus or minus the square root of 32 all over 2. And now we need to look and see if we can simplify that square root. Well, 16 is actually a factor of 32, and 16 is a perfect square. So I'm actually going to break this down now into 8 plus or minus the square root of 16 times 2 over 2. And if we simplify that now, square root of 16 is 4, so we can bring that to the outside of our square root, leave the 2 inside, and we're still over 2. Now this time, because all of our numbers on the outside of the square root are divisible by that 2 in the denominator, we can actually do that. Okay, so I'm going to divide 8 by 2. That's going to give us 4 plus or minus, and then 4 divided by 2 is 2, and then we keep the square root of 2. So again, I'm just dividing each of those terms. 8 divided by 2 is 4. 4 square root of 2 divided by 2 gives us 2 square root of 2, and we keep the plus or minus. Now, remember, this is what x squared is equal to now. So now to find the x value, we still need to solve what we have over here. However, it's really not too bad at that point because we have this nice equation that says x squared equals this. And so all we really have to do is just take the square root of both sides. So I'm going to take the square root of this. I'm going to take the square root of this. That gives us our x. Don't forget, we need a plus or minus on the outside. So we get plus or minus the square root of 4 plus or minus 2 square root of 2. And as ugly as that looks, okay, those are the solutions now to that equation. Now, understand here, there are technically 4 solutions in there, because if I have the positive on the outside, I could take either the positive or the negative on the inside. That gives me 2 of my solutions. Then I could put the negative on the outside and again take either the positive or the negative. That gives me 2 more solutions. And so there are actually 4 solutions embedded in that solution right there. All right, last example. Okay, so we want to find the solutions here to the absolute value of 2x minus 5 is equal to 3. Now, what we have to think about in this case is what could go inside that absolute value that would give us a positive 3. Well, the absolute value of 3 would give us 3, but the absolute value of negative 3 would also give us 3. So the stuff inside this absolute value could either be equal to 3 or it could be equal to negative 3. So I'm going to take everything inside here, 2x minus 5. I'm going to set it equal to positive 3. But then I'm also going to take everything inside and I'm going to set it equal to negative 3 instead. Because in either case, once I take the absolute value, it's going to come out as a positive 3. Now we just solve. So we're going to add 5 here. That's going to give us 2x is equal to positive 8. We divide by the 2. That's going to give us x is equal to 4. Now on the other side, we add the 5. That's going to give us 2x is equal to positive 2. Divide by your 2. That's going to give us x is equal to positive 1. And so these are the 2 solutions to that equation. And we don't have to test anything, right? Those solutions are going to work as long as your original equation was equal to a positive value. Now, if I substitute them in, you can see that it does work. Plug in 4. 2 times 4 is 8. 8 minus 5 is 3. Absolute value of 3 is 3. If I plug in the 1, 2 times 1 is 2. 2 minus 5 is negative 3, but the absolute value of negative 3 is indeed positive 3. And so both of those solutions check out now. All right, so that's all we've got for equations. As always, let me know if you've got any questions about anything. Continue to work on that homework, and I will see you next time.